Okay, so we're gonna do 7.3 polar coordinate. Okay, now we have Cartesian plane, XY plane, right? So we call that. Look, then we have angle theta there. So from origin to here, the radius, right? We called. Okay, now we have a point. We denote like a point P and order pair X and Y. Okay, look. In right triangle, we denote cosine theta. Let me write down here. Cosine theta, which is adjacent side over hypotenuse, right? Okay, so in this case, we are standing here. Adjacent side will be where? It's here, right? Adjacent side. But this one we call the X there, right? This is the X, same X, right? So it's X, hypotenuse. So longest one is the hypotenuse, which is R, right? Good, okay. Now, we want to solve for X. So X equal to times R, so we get the R cosine theta, right? R. Every time when I sound the R, sounds like a dog. Okay, now we have a sine theta. Sine theta in right triangle, we denote like opposite over hypotenuse, right?
That will be y over r.
Very good. So we have y over r. Good. Now solve for r. I'm sorry, y. Then times r both sides, so we get the y equal to r sine theta, right? Okay, so we have that. All right, thank you for letting me know. Yes. Okay, now we know that this one from the, which one? The not pre-calculus, yeah, pre-calculus and trigonometry courses, right? And r squared, how do we know r squared, which is x squared plus y squared by Pythagorean identity? I mean, Pythagorean theorem, right? So r squared x squared plus y squared. And tangent theta, it's the same, right? Opposite over opposite over adjacent, right? So that is, this is from trig, right? So y over x. Okay. All right. Now we're talking about polar coordinate. So this is r theta, like a Cartesian coordinate, which is xy, right? So that is the order pair in Cartesian plane. We call the Cartesian plane. Okay. Now we called, let me bring here, screenshot. Cut. First coordinate, which is x, second coordinate is y in Cartesian coordinates, right? But polar coordinate, which is r theta, so we call the first one as the radial coordinate. Okay, like radius, right? And the second coordinate, which is angular coordinate, which is angle theta, right? the name, okay? Angular coordinate and radial coordinate, right? Okay, so we're gonna use this, the definition. So we're gonna converting from Cartesian to polar, polar to Cartesian, all right? Okay. So let us do just a couple problems, each one. We have convert. Into polar coordinate. Okay, so we have the first one, 1, 1. So we can see easily this is just Cartesian, Cartesian, right? So just regular XY coordinate. Now we want to make r theta, converting. Okay, so we're gonna use r, the first coordinate, which is r equal to, which is r squared equal to x squared plus y squared. So 1, 1, so 1 square plus 1 square, which is 2. Yeah. r equal to, since radius, we make just a positive, square root of 2. Okay, theta. Theta will be what? Tangent theta, right? Tan theta, which is y over x, which is 1 over 1, which is 1. What's the theta will be?
Pi over 4.
Very good. So pi over 4. So we're gonna have r theta, which is a polar coordinate, which is square root of 2 and pi over 4. Very good. Okay. Now let us do second one. We have a -3, 4. This is xy. We want to make r theta. Okay. All right. So r squared, which is x squared plus y squared. So what do you get this one? Oh,
25.
25, good. Which is 5. Very good. Now theta, tan theta. Which is y over x, which is 4 over -3. Okay, so since this is not nice number, right? So we're gonna do inverse of a tangent. So we will have inverse of a tangent over this. So what do you get this one? What do you get? So I think you get this one point, negative point in radians.
927.
27 to, how about
29.
0.2928, how about that, right?
Yes.
Okay, then this means so angle from here. Okay, that is -0.2928. Yeah, but then the inverse of a tangent, the range is between between negative pi over 2 to pi over 2, right? So we don't want, we want, look, y equal to positive, x equal to negative. What's the quadrant will be? X equal to negative, y equal to positive. This is quadrant 2, isn't it? Yes. So we're gonna have the angle theta here, quadrant 2. So how do you find? So we're gonna use a reference angle. So reference angle, you might not remember, that's fine. So reference angle, only there is a 4 types. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. But quadrant 1 is just as it is. That's why I said the 3 types, okay? Quadrant 1, same as the reference angle, same as the original one. Quadrant 2, then pi, because pi is always the closest to 1 by the x-axis. So pi minus the angle. So we are using pi minus that angle, 0.928. That is the answer. What do you get? If the angle is in quadrant 3, then we say that pi plus that angle. Okay? If angle is in quadrant 4, we are using 2 pi minus that angle. That is the reference angle we are looking at. Okay? Okay, pi minus 0.928, you got 2.21. Okay. All right. So second one we did okay, what about the reverse? We do converting polar to the rectangular coordinate. So what's the number? E and F.
What's that writing in the purple there? Is that in, are those E's?
If angle is belong to the angle is belong to like this is belong to.
Oh, okay.
Yeah.
Is it an at? Are those at symbols?
Yeah, it's like look like E, right? But it's like that belong to.
Oh, okay. Thanks.
Yeah, sorry about that.
No,
It's
it's
yeah, it's a belong to. It's a short way mathematical symbol. Okay. All right.
thanks.
Because there's no space, that's why.
Uh-huh.
Okay, so E, we have R theta. Let me write down. Convert each of the following. Points into rectangular coordinate. Okay, so we have, in this case, 3 and pi over 3. So this is R theta, okay? Now, we want to find the coordinate, which is x and y. All right, so x equals, oops, Oh, yeah, I needed that formula. X equal to R cosine theta, right? And Y equal to R sine theta, we're gonna use that. I didn't intend. Okay. R equal to R cosine theta, I'm sorry. X equal to Y equal to R sine theta. So R in this case is 3 cosine pi over 3. What do you get?
3 over 2.
3 over 2. Good. We have 3 sine pi over 3. What do you get? It's okay. Square root of 3 over 2. All right. Now, done. Oh, that's it, right? So we have xy, which is 3 over 2. 3 square root of 3 over 2. Okay. Second one. We have 2 and 3 pi over 2. Okay, so this is our theta. Okay, we can recognize the second one as a theta, right? Then we want Cartesian, which is xy coordinate, rectangular coordinate system. So we have x equal to r cosine theta, which is 2 cosine 3 pi over 2. What do you get? Zero? Zero, right? How about sine 3 pi over 2?
-1.
-1, which is -2. Okay, very good. All right. Okay, so I'm gonna bring the polar coordinate system here. Look. Copy, because I'm gonna use it later. Okay, this is the look. Is it big enough to see? This is a similar look, like the unit circle, right? So we have a pi over 6, we have a pi over 4, we have a pi over 3, pi over 2, right? And 2 pi over 3, we know that 3 pi over 4, pi over 5 pi over 6, and pi. Yeah, this one we know that, but only difference, they have more, right? They have more, like pi over 12 and 5 pi over 12. Okay, how do we get the degree? This one. Times degree mode 180 divided by pi, right? Yeah. Because 180 degree the corresponding pi, right? So we multiply that 180 divided by 12, what do you
15.
get?
15.
15. So this is a 15 degree. Then we kind of notice, right? Get an approximation. 15 degree, 30 degree, 45 degree, 60 degree. How about this one? 180 degree over pi. How about
75.
75? Oh, good, thank you. 75 degree, all right? So there is add more dividing, right? 15 degree and so on, right? Yeah, they can create whatever they like, right? Polar is about the angular one in the second coordinate, right? Okay, now we're gonna plot the point. Polar plane. So we had a Cartesian plane, which is XY plane and rectangular plane, right? Now they using polar as a polar plane, all right? So all theta, right? Okay, now we have the first one is 2 pi over 4. And second one, -3, 2 pi over 3. And the third one, 4, 5, 5, 5, 5, 5, 5 pi over 4. Okay, look, let me bring one more thing. Oh, no, sorry. Cut. It's big enough to see. All right, so 2. So how do we measure 2 radius? So this is 1. Okay. Let me write down. This is r equal to 1. And this one r equal to 2. And third one r equal to 3. Then fourth one r equal to 4. R equal to 5th. And we can more drawing, right? 6, 7, 8, 9, 10, right? Okay. All right. So in this case, the first one is R. Second one is theta, right? R equal to 2. So 1, 2, right? So we're going to start here. Or we can make theta first, so that's fine. Okay, so theta equal to pi over 4. That's why I needed this one. Because we are we used to have unit circle, right? So which is start pi over 6, pi over 4, pi over 3. But in here, they added pi over 12 and 5 pi over 12, right? All right, so once again, 2n pi over 4. That's it, 2n pi over 4. This will be 2, because radius is 2, right? And pi over 4. So this one. Yeah. So that is the point. I want to plot. Normally we measure angle like that, but then the point, there's the plot the point. So this will be the point. Okay, so let me write down. So this is a 2 pi over 4. Okay, now -3. 2 pi over 3, okay? So I know 2 pi over 3 there. Here, right? So 2 pi over 3 from here to here, right? But then -3, right? But we just want, this is radius 1, 2, 3, okay? How do we indicate the -3? Okay, watch. I say that this is the 3, right? So 3 and 2 pi over 3, 2 pi over 3 is here, right? So that is the. Okay, now This is not answer. This is, I just give it to you reference. How we plot the point 3 and 2 pi over 3, right? Now, the answer, we want to look for -3. So which is the opposite way, okay? So opposite of, then this will be 5 pi over 3 there. I mean the 3. 1, 2. Yeah, so that's correct. But then we don't indicate that there is a 5 pi over 3. We make a look opposite side. Opposite, I'm following that. Giving you 1, 2, there's a 3, right? So 1, 2, opposite way. Yeah, this one, right? So 1, 2, 3. Yeah, this will be -3, 2 pi over 3. Make sense? So let me write it down. -3, 2 pi over 3. Okay, so first of all, we plot the 3, 2 pi over 3 first, then the radius is the opposite is -3. That's how we plot the polar coordinate. Okay, so this is -3. And we don't describe this as a 5 pi over 3. We describe this as a 2 pi over 3 as well. Okay. Okay, the last one, 4, which is 1, 2, 3, 4. Radius is 4, and 5 pi over 4. 5 pi over 4 is here, right? This plot is done. Okay, so let me write down. So this is 4 and 5 pi over 4. Okay, that's it. And there is a more polar curve. Take a look, it's beautiful. And then also the equation as well, okay? All right, thank you for coming.